Hey children, welcome to Station 5. Station 5 is about analyzing exponential equations. So if you remember, an exponential relationship is one where something is either happening very slowly at first and then it just escalates very quickly, or where something kind of calms down really fast and then just kind of stays calm. So that's what an exponential relationship looks like. It's kind of like a swooping line, and we analyzed that both when we did scatter plots and when we were talking about other types of relationships. Now, when you have an exponential relationship, you will have your variable as an exponent. That's why it's called an exponential relationship. You have an exponent variable. Now, this equation has some pretty crucial parts. So you have A, you have B, and then of course you have the exponential variable. Now, A is what we call, if you remember, the initial value. And hopefully you can make Ms. Barrow proud and realize, oh, initial means like beginning. That's true. It's the value that your equation or your relationship begins at, which in our case means that it tells us our y-intercept. Okay, so just like when we had sloped intercept form and the b would tell us our y-intercept, now it's actually a because it's a different form of equation. Now b does something a little bit different. B can actually tell us a lot of information about our function. It'll tell us, this is called the growth rate, and depending on its value, it'll tell us if we have a growth function or a decay function. Now there's two options here. Your two options are this. If b is bigger than 1, a number that's bigger than 1, then you have a growth function, which means it's growing. But if b is less than 1, it's not a whole number, it's a decimal, this means you have a decay function. Okay. So now that we've summarized that, we're going to come down here, we're going to read the directions. It says identify the growth rate, so remember that's b, and the initial value. In a complete sentence describe, so in a complete sentence, remember that part, it's important. In a complete sentence, describe the y-intercept of the function and whether it is a growth function or a decay function. Okay, so they want to know the growth function or if it's decay function, but they also want to know what the y-intercept is, so that's important to know. Color the growth function light blue and color the decay function light green. So if you finish, you can go ahead and do that. But the focus here is more for you to be writing about what the intercept is and what the growth, whether it's a growth or decay function. So if I look at this first one, the first thing I want to do is I want to identify the initial value and the b value. So I'm going to write a equals and b equals. So I can see a is here and b is the number that's to the power of x. That's how you know what b is. So here I know a is 5, which means my intercept is 0, 5. And here I know b is 1/2. So I could say the y-intercept of this function is 0, 5. It is a decay function because 1/2 is less than 1, period. Okay, so I identified the y-intercept of the function, which is 0, 5, the initial value, and I said it's a decay function because 1/2 is less than 1. So I gave the reason why it's a decay function. So let's look at this one here. if I look here, I can say, alrighty, A, where's my pen? A is 3 in this function, okay? 3, and B is the number that's being taken to the variable power is 0.25. And if A is 3, that means I have the 0.03. And again, I could write a sentence. I could say, this function is a decay function because 0.25 is less than 1 and its y-intercept is 0.3. And all done. I wrote my complete sentence telling you whether it was a decay function or a growth function, and then I also told you what the y-intercept would be. Okay, so on this page you have 10 more problems to do, and for each of them I do expect this exact same method. Write down the A value and the point, write down the B value, write your sentence, and then once you've done all that, you can go ahead and color according to which one is growth function or which one is the decay function. That way it's easier for me to check at a glance whether you could really identify those differences. Okay, go ahead, get started. I will see you at the next station.